are being recorded. All right, Gabe has a question, actually two. All right, page 228. Numbers 13 and 21. Okay, I'm actually glad you're asking for number 13. They're actually from the book, from the same section, but that's all right. Okay, so page, whoops, let me get my marker. All right, page 229, number 13. All right, so it says test each of the following equations for symmetry. And number 13, the equation is y squared equals x plus 1. All right. All right, so this is the original equation that they gave you, and they typically always ask this in the same order, so I'm going to use it in that order. I'm going to say part A, part B, and part C. So for part A, they're going to ask for symmetry with respect to the y-axis. For part B, symmetry with respect to the x-axis. And then part C, symmetry with respect to the origin. And I'm going to read the directions to you that they have in the book, and then I'm going to read the directions that were on your quiz today. So in the book, it says, test each of the following equations for symmetry. In your, on your quiz, it was number 10. It says, using the tests for symmetry, show, and it has a big fat, I'm going to write this in red here, all caps, show whether the following equations graph has symmetry with respect to the y-axis, the x-axis, and the origin. Okay, so the key word is show. It was all in caps. It was bolded. And I cannot believe that some of you on your group quiz just answered yes or no and didn't show one single thing. So you got 0 credit. I don't care if you put a yes or a no. It doesn't matter. You didn't show anything. So you have to know that symmetry with respect to the y-axis, what you're going to show is plugging in a negative x wherever there's an x in your equation. So I'm going to show that by writing this negative x and then writing everything else the same. Now, if that can be simplified, you want to. This actually cannot be simplified. And what I'm looking for is whether or not this is equivalent to the original equation. And it is not. And so symmetry with respect to the y-axis for this problem is a no. Okay, then I go to symmetry with respect to the x-axis. For this, you show that you're plugging in a negative y instead of the y, and then you write everything else the same, and then you simplify if you can. Now that first one, I couldn't simplify that, okay? There's a negative for the x, it's not equivalent, and that's it. But here, when I square that negative y, don't you get y squared and then x plus 1? So look at this equation. Isn't it exactly the same as the original equation? So for symmetry with respect to the x-axis, that is a yes. And then symmetry with respect to the origin, even if you think you know what the answer is, you're still going to show your work. So for origin, symmetry with respect to the origin, you show a negative y instead of the y, and a negative x instead of the x, and everything else stays the same. And still, I'm going to simplify. So my negative y, the quantity squared, becomes positive y squared. Then I have equals negative x plus 1. I can't do anything to that. This is my simplified function, and when I compare it to the original, it is not equivalent. And so for the origin, that one is a no. So my answers are no, yes, no, but more importantly, this is my work that shows what I was supposed to do, okay? So be prepared for a -3 for those of you who didn't show anything. Okay, Gabe, I hope that made sense to you. We're going to do the same thing now with number 21 on the same page, page 229, number 21. All right, and that one says the original equation, y equals x to the 4th minus, oops, it was a 2, but no, it's a 4x squared. Okay, so symmetry with respect to the y-axis, B, the x-axis, and C, the origin. All right, I'm just abbreviating. Okay, so box this. This is my original equation. I'm going to use the same colors as I did the last time. So for symmetry with respect to the y-axis, I write the y. Where I see an x, I'm going to plug in a negative x. Notice I put it in parentheses. It's like the skeleton of this function. And then instead of the x, I write a negative x in parentheses and then squared. Okay, you need to show the step of simplifying this. When I raise -1 to the 4th power, I get +1. And then when I raise x to the 4th power, I get x to the 4th. Okay, my negative x, the quantity squared, becomes positive x squared. And so this becomes -4x squared. Isn't this exactly the same as the original equation? So those are equivalent. And that means yes for symmetry with respect to the y-axis. All right, next I'm going to do for symmetry with respect to the x-axis, we plug in a -y instead of the y, and then everything else stays the same. Now, I could just stop right here and compare this to the original equation. It is not equivalent. Perhaps some of you will say, oh, I could multiply both sides by a negative. You could. Let me write this in black. You would get +y equals -x to the 4th, no parentheses, plus 4x squared. And even if you did that, do you agree this equation is also not equivalent to the original? And so for symmetry with respect to the x-axis, it is a no. All right, and finally, symmetry with respect to the origin, I plug in a negative y for the y. Then, because that x is being raised to the 4th power, I have to put that in -x in parentheses, -4, and then -x squared. All right, I'm going to leave the -y alone. The second, or the -x to the 4th becomes +x to the 4th, and this becomes -4x squared. This is still not equivalent to that original equation, and so this is also a no. So my final answers are yes, no, no. But more importantly, this is my work that I am showing why it's a yes, no, and no. Okay, there you go, Gabe. Okay, Gianna, could I do page 270, number 43, and then we'll go to the next one. All right, 270. Okay, so this is from the review. And you said 43. Yes, okay. I imagine people will ask for this in class, but we'll tell them they should watch the GBO because I'm doing it now. All right, so page 279, number 43. Okay, so we talked in class about ratios that can either be written with the word TO in the middle, for example, 1, and then the word 2, 1 to 3, if that's my ratio. But you can also write that ratio as 1/3 or 1:3. Well, in number 43, they give you a ratio that has 3 different things that we're comparing. It says a concrete mixture calls for 1 part cement, 2 parts sand, and 3 parts gravel by volume. So I'm going to write that as a ratio with colons in between. And so I'm going to say there's 1 part sand to, 1 part cement to 2 parts sand to 3 parts gravel. Okay, so it's my ratio. It's a 1 to 2 to 3 ratio. But I want to specify what each of the parts stand for. So the 1 part stands for cement. I'm going to put a little C right there. 2 parts of sand. I'm going to put a little S. And then 3 parts of gravel. So I'm going to put a little G. All right. It says how much concrete. By the way, if you mix together the cement, the sand, and the gravel, all together you get concrete. So it says how much concrete can be made from 4 cubic meters of cement. Well, this C right here tells me this 1 part is cement. Well, they just told me what the actual volume is. It says 4 cubic meters, and here's how you write cubic meters. I know you guys would probably say meters cubed, but that is incorrect. It is cubic meters. It means 1 meter by 1 meter by 1 meter. It's volume, okay? And by the way, a meter is actually bigger than a yard. So that's actually quite a large volume. All right, so I have 4 cubic meters of cement. Well, if I just look at this portion of my ratio, 1 to 2, you should be able to tell me how much, or how many cubic meters of sand there are. Because if the 1 stands for 4 cubic meters, then doesn't it mean that you have twice as much sand, or 8 cubic meters of sand? Okay, because of the 1 to 2. If the 1 stands for 4 cubic meters, then doesn't the 2 stand for 8 cubic meters? And now I'm going to take the 1 and compare it to 3. So I'm just using the ratio 1 to 3. And I'm going to be able to figure out how much actual volume of gravel that I have. If the 1 part of cement, stands for 4 cubic meters, then doesn't the 3 mean 3 times that amount? And that is 12 cubic meters of gravel. So we said that when you add all 3 of those things together, cement and sand and gravel, you get concrete. And they said, how much concrete would you have? So I'm going to add up the 4 and the 8 and the 12, and I get 24 cubic meters of concrete. And that is your final answer. Okay, does that make sense? Okay, that was Gianna's first question. All right, second question is page 263. Page 263, number 34. All right. Okay, so this is a variation problem. It says the weight W of a body above the surface of the earth varies inversely as the square of its distance d from the center of the earth. Okay, so writing the equation actually should be easy. I think the part that is a little tricky about this problem is understanding what the W stands for, and most importantly, what the D stands for. All right, so the weight of a body above the surface of the earth varies. Varies is my verb, so I'm going to write W equals. Every variation problem has to have the constant of variation, so there's my K. Okay, so the weight W varies inversely as, so I know it's going to be divided by, the square of its distance. Now, I did not read the square root of its distance. It said the square of its distance. So look what I'm going to do to the D. I'm going to square it. That is the square of D. All right. And let's draw a little tiny picture of what D stands for. I'm going to read it to you, and then I'm going to draw a picture. So it says that its distance D from the center of the earth. Okay, so if this is the earth, and by the way, they tell us that the radius of the earth is approximately 4,000 miles. 4,000 miles. There's the radius of my earth. Okay, and then D is the distance from the center. So if a body is out here in outer space, this distance is what we're calling D, the distance from the center of the earth. So it's the 4,000 miles, that's my radius of the earth, plus however far above the surface of the earth this body is. Okay, all right, so that's what D equals. Assuming the radius of the earth is 4,000 miles, how much does a person weigh 200 miles above the surface of the earth? Now, I'm quite aware that this is not to scale, but they're telling me that this distance right here is 200 miles. So I know my picture's not to scale, but isn't my D then 4,200 miles from the center of the earth? 4,000 miles for the radius, plus 200 miles above the surface of the earth. So my D is 4,200 miles. And it says, how much does a person weigh 200 miles above the surface of the earth if, oh, by the way, they're giving me D and they're saying, how much do they weigh? Well, I can't answer that question yet. I don't know what K equals. So those two things go together. That's the actual question. Then it says, if he weighs 180 pounds, so they're telling me what his weight is, 180 pounds. on the Earth's surface. Well, what do you think your D is if this 180-pound guy is on the Earth's surface? Well, look at my picture. That means he's 4,000 miles from the center of the Earth. So we're going to use this second set of information to solve for K, and then we'll be able to answer their question. All right, so I put a 180 instead of a W. I don't know K. And then for D squared in the denominator, I'm going to write 4,000 squared. And now to solve for K, I'm going to multiply in my calculator. I think I'll do the 4,000 squared first and then say times 180. And I get a very, very large number. It is 288 and then 2, 4, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. I'm going to go back and put commas and commas and commas. So 1,000, million, billion. Excuse me. My K is 2,880,000,000, and that's my K. Therefore, my equation, particular equation, becomes W equals 2,880,000,000 all over D squared. Okay, so that's your answer for write the particular equation, if they asked you for that. And now we're going to answer their question. They want to know what will W equal when this same guy who weighs 180 pounds on Earth, when he's 200 miles above the surface of the Earth. So I'm plugging in for D, 4,200, and don't forget, it's squared. Okay, so I already had my 2,880,000,000 in my calculator, so I can go divided by 4,200 squared, and then hit enter, and I get that he would weigh approximately, where can I put this? Let me put it in red, I guess. W would be approximately 163.27 pounds. And I have no idea how they rounded in the back of the book, but there you go. Okay, so it's a little bit lighter, but not that much. Okay, yeah, you could use scientific notation. We specifically skipped the section on scientific notation. Actually, that might be my Algebra 2 trig class. I don't believe we've done scientific notation in here, but they're not going to give you numbers that you can't do in your calculator, so you're fine. Okay, Sarah, I'm going to do a couple of your problems, and then I'll continue and answer some other questions, and then I'll come back and do a few more of yours, okay? All right. Yeah, Gianna, you asked about, okay, yes, you answered yes. All right. Okay, let's see. Okay, so Sarah has a few questions on the quiz. Let's go to those. All right, so quiz number 13. Okay, let's see. They gave us 9x squared plus 4y squared minus 54x plus 8y. Now, Sarah, I know in Mr. McKee's class, I don't believe he changed it, but it said, the quiz originally said minus 49. I changed that to minus 59 because with the minus 49, you got really bad numbers. Okay, so I'm writing that in red so it stands out. And I had my students change it to that. All right, so I'm going to do it like this because it makes the numbers much nicer. Okay, so what you want to recognize is that I have, if I just look at the first two terms, I should be able to already know what this is. I have both the x and the y are squared. My coefficients are both positive, but they're not equal, so I immediately know that this is an ellipse. All right, so I'm going to gather up my x's. I want the 9x squared. Next, I want the minus 54x, and I'm going to write plus blank, but I'm not ready to complete the square yet. Next, I'm going to write my y's. So plus 4y squared plus 8y, and then plus blank, but I'm not ready to complete the square there either. And then equals positive 59 plus blank and plus another blank. All right, and so I'm writing those plus blanks so that I don't forget when I complete the square on the left side, I have to balance it out on the right side because that's what algebra is all about. Okay, so those of you who want to take half of 54 and then square it, you do not realize that that is only the two steps you take if your leading coefficient is a 1. Well, it's not. It's this 9. And for the y squared, it's this 4. This has to be your first step. You must factor out the 9 first out of these two terms. And so I'm going to get 9, the quantity, x squared minus 6x, and now inside my parentheses, I am ready to complete the square. Okay, so because my leading coefficient of x squared is a 1, then I go to my negative 6, I take half of it and square it, so that's a plus 9. However, this 9 in front of the quantity affects that 9, and so I have to add not 9 to the other side, but 81. Okay. All right, next I go plus sign and then factor out the 4. So I get y squared plus 2y and then plus blank. I take half of the 2, that's 1, square it, I still get 1. However, the 4 in front affects that 1. So what am I going to add to the other side? Not a 1, but a 4. Okay, when I add the 59, the 81, and the 4, I get 144. Okay, so I'm going to have 9. I'm going to factor this, x minus 3, the quantity squared. I'm going to end up going divided by 144 because I know the equation of an ellipse needs to equal 1. So for my next term, I get plus 4, the quantity, y plus 1, the quantity squared. That will also get divided by 144 and then equals 144 over 144. Okay. 9 goes into 144, I believe 16 times. And 4 goes into 144 36 times. There we go. So I have x minus 3, the quantity squared, over 16, plus y plus 1, the quantity squared, over 36 equals 1. So all of that was to get this equation in standard form. Okay, here are the pieces of information you should know because of this equation. I know the center of my ellipse is the point 3, negative 1. I know my x radius is 4 and my y radius is 6. Okay, I'm going to assume you can graph that. Okay, it is a, well, actually, I want to show some more. Okay, I'll go ahead and graph it on the next page. So I said that the center was 3, negative 1. So 1, 2, 3, negative 1. With an x radius of 4, I'm going to go to the left, 1, 2, 3, 4. Put a point. Go to the right, 1, 2, 3, 4. Put a point. My y radius is 6, so I'm going to go up 1, 2, 3, 4, 5, 6. And down, 1, 2, 3, 4, 5, 6. Okay, and since this is longer going in the y direction, sorry, that's a little not very smooth. When I go to find my foci, they're going to be going in the y direction. That's the main reason why I'm graphing this for you. Okay, they asked you to find the coordinates of the foci. So first I have to solve for c. So since my equation for an ellipse is a plus sign in the middle, this is going to be a squared minus b squared. And from your equation, you had 36 in the denominator of one fraction and 16 in the denominator of the other. And so I get c squared equals 20. When I take the square root, though I should be thinking, don't forget plus or minus because it's a quadratic equation. If I consider c to be my distance from the center, then I'm just going to say the square root of 20. But that simplifies to 2 rad 5. And to know where to put it on my picture, on my graph, I'm going to find the decimal approximation of that. I actually don't have that written down. Square root of 20 is approximately 4.5. So from my center of my ellipse, I'm going to go up 1, 2, 3, 4.5. It'll be about right here. And then down 1, 2, 3, 4.5 is about right here. Okay, they asked you to write the coordinates of your foci, and I told you guys at the beginning of the quiz that I didn't mind if you wrote it this way. Let's see, this is number 13. So my center is 3 comma -1. I personally would ask myself, what is in common with all three of those points that lie in a vertical line? And it's that their x coordinate is 3. Now their y coordinate ends up being -1 plus 2 rad 5 and -1 minus 2 rad 5. And so I'm going to put those together and say -1 plus or minus 2 rad 5. And since they asked you for that and in the answer column, I'm fine with you writing them together, but I do want your graph to show me where the foci are. Okay? Okay. That was number 13 on the quiz. All right. Quiz number 15. All right, same concept. I'm going to go ahead and start gathering up my x's right away. Okay, so 25x squared plus 200x. I'm going to write plus blank, but we're not ready to complete the square yet. Minus 4y squared. Next, I have plus 8y. I'm going to write plus blank, but not ready yet. And then equals negative 296. And then underneath that, I'm going to write plus blank, so I don't forget to complete the square on both sides. All right, because of this 25 and this -4, you cannot go to your middle term and take half and square it. You have to factor out the 25 first. So I get 25, the quantity, x squared plus 8x. Now I'm ready to complete the square. So half of 8 is 4, squared is 16, and 25 times 16 is 400. So I'm going to add 400 to the other side as well. Okay, here's where I'm worried about you guys. I'm factoring out a -4. That leaves me with y squared, and I'll bet you quite a few people will get this next term wrong. You need to look at your signs carefully. It's minus 2y. So the -4 times -2 gives me plus 8 times y. All right, then I'm ready to complete the square. So I take half of my -2, square it, that's 1. But because of the -4 times 1, I'm going to subtract 4. And when I combine all of those terms together, I get positive 100. Okay, so I'm going to go over 100, over 100, over 100. And so I'm going to get, as I factor, x plus 4, the quantity squared, all over 4, because the 25 and the 100 simplify to that, minus y minus 1, the quantity squared, all over 25, equals 1. And there's my equation in standard form. And here's what you should know about your, by the way, this is a hyperbola because of the minus sign in between. This is a hyperbola that opens left and right. I'm just going to put that little picture to remind myself. The center of my hyperbola is -4, 1. The x radius is 2, and the y radius is 5. Okay, and it's opening sideways because with the minus sign in the middle, the x is the leading term. So it's opening in the x direction, which is left and right. Okay, on the next page, let me draw the graph. Okay, so we said center is -4, +1. 1, 2, 3, 4, -4, +1. Okay, with an x radius of 2, I'm just going to go to the left and to the right 2. With a y radius of 5, I'm going to go up and down 5. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. That's a -4. And then that gives me my fundamental rectangle. A little bit off. I'm going to draw the asymptotes, which are the diagonals extended. And we already said that these are going to open sideways, the hyperbola branches. So this point becomes very important. And same for this point. Those are called the vertices now of my hyperbola. So my branches start from that point and go toward the asymptotes in both directions. And so this is what my graph looks like. And now I'm going to solve for c. C squared, since the equation for a hyperbola has a minus sign in the middle, this is going to have a plus sign in the middle. So c squared equals a squared plus b squared. Since it's a plus sign, I don't have to worry about which one's smaller or larger. And so my two denominators are 4 and 25. If you want to write 25 plus 4, that's fine. We're both going to get 29. So c equals the square root of 29, and that is approximately, I don't have that either written down, square root of 29 is approximately 5.4. And the only reason I need that is to be able to plot my foci. Okay, I heard several groups debating whether they should be counting from the vertices or from the center. So let me be very clear. Just like the equation, or I shouldn't say equation, just like the graph of an ellipse, you go from the center of the hyperbola also. However, what's different from the ellipse is in an ellipse, you go in the direction of the major axis. Here you go in the direction of how your hyperbola opens. This hyperbola opens left and right. And so from the center, I'm going to go to the right, 5.4. So that's 2, 3, 4. 5.4 would be about right here. And then to the left, 5.4, 1, 2, 3, 4, 5.4 would be about right here. Okay, and they asked you in the answer column to label the coordinates. And so I'm going to write that this is negative 4, comma 1. And since my foci go in the x direction, it's the negative 4 that's going to get added and subtracted from. So plus or minus square root of 29, comma 1. And there are your foci. Okay. I think we're going to take a break on Sarah's questions. All right. Andrew is asking for page 220, number 17. All right. Page 220, number 17. Okay, this is the equation, or they're asking us whether it's the equation of a circle. So x squared plus 2x plus y squared plus 6y equals 0. All right, so I really should have squeezed in my plus blank, but let me go ahead and do so now. So x squared plus 2x, and then I need to complete the square there for my x's. Then I have a plus y squared plus 6y, another plus blank, and then equals 0 plus blank plus blank. All right, because my leading coefficient is a 1, I take half of that 2, which is 1, and square it, which is 1. And so I also add 1 to the other side of my equal sign. For my y's, because my coefficient is 1 of the y squared, I take half of 6, which is 3, square it, I get 9, and so I add 9 to both sides. All right, left side, this becomes x plus 1, the quantity squared. Second term, after I factor, I'm going to get y plus 3, the quantity squared, and all of that equals 10. So yes, this is a circle. If it is, it says find the center and radius, so let's label that. The center will be negative 1, comma, negative 3. And the radius is the square root of 10. And there you go. Okay, let's see. That was Andrew's question. All right. Gianna's asking for how to find the asymptotes, and yes, it was of a hyperbola. If I go back to my example of a hyperbola, yeah, they're not going to ask you for the equations of these asymptotes because this center was not centered at the origin. Okay, so I'll just show you kind of a made-up graph of a hyperbola that they would ask you for the equations of the asymptotes. So let's pretend the center of your hyperbola was at the origin. Okay, we did a whole section on that. And let's say that your x radius was 4. So you went to the left and right 4. And then let's say that your y radius was 3. You went up and down 3 from the center. And so here's your fundamental rectangle. And then here are the asymptotes that they might ask you for the equations of them. Okay, so if you're going to write them in y equals mx plus b form, of course we need our slope, m, but we also need to know our b. Well, look at where these two lines cross the y-axis at 0. So my b is just a 0. And so I get y equals, let's look at how to get from one point to another. So from this center to this point right here, didn't I go up 3 and to the right 4? And so my slope is 3 over 4 times x. However, if I look at my other line, there's two asymptotes. I go up 3 and left 4, and that just gives me a negative 3/4. So I'm going to shortcut it and write them together. Y equals plus or minus 3/4 x would be the equations of these asymptotes. Okay, so it has all to do with the slope. Alrighty, so Gianna, that should have helped. Okay, I think I'm back to Sarah's questions. Let's see. Okay, Sarah asked, with the negative 49, would you have gotten something along the lines of, yeah, I don't know, I didn't do it with that. As soon as I saw that the numbers didn't work out well, I went, what do I need to change this to make it nicer? But the 134, yes, so you'd have the square root for your x and y radii. You'd have the square root of 134 over 3 and the square root of 134 over 2 for your x and y radius, which you would then just approximate and still be able to draw your graph fairly accurately. Okay, now I'm going to go back to some of Sarah's list of questions. We did not do 16 and 17 on the quiz, but we can. All right, quiz 16. All right, it says the equation 2x minus 6y equals 12, defines a function f. Find the expression for f of x. Well, f of x, I think you guys all know, is another name for y. So they're basically just asking you to solve this equation for y, which should be pretty easy, but call it f of x. So I'm going to leave the negative 6y alone. Subtract 2x from both sides, and then I have my plus 12. So next step is to divide by negative 6, so I can get y all alone. So I get y equals positive 1/3 times x minus 2. However, they asked us to write an expression for f of x, and f of x is another name for y. So my answer is f of x equals 1/3 x minus 2. And there you go. All right. Number 17 on the quiz is asking us to find the inverse, f inverse, for the function given in this problem that we just did. All right, so for quiz number 17, I'm going to write my original equation that I just got. Actually, I'm going to write it with just the y equals instead of f of x, because my first step is actually to write y instead of f of x. So that's what I'm doing right now. Okay, so there's my equation with y instead of f of x. The next step is to switch the x and the y. Okay, the next step is to solve for y. So I'm going to leave 1/3 y alone, add the 2, and finally multiply everything through by 3. And so I get y all alone. Over here I get 3x plus 6. And instead of the y, I'm going to write f inverse. That's what I just found. And they didn't ask us to graph it, okay? But if I did graph this original function up here and this inverse function here, they better be perpendicular. I'm saying both of those wrong. They better be reflections of each other over the line y equals x. That's the relationship. Reflections of each other over the line y equals x. Okay, let's see. That was number 17. Okay, Sarah's other questions come from page 220. And question on number 22. Okay, and you have 22, 24, 20. I'm going to pick one of those because those are so similar. I think I'll do number 24 instead of number 22 just because there's a little something that you have to do. All right, so as soon as I see the original equation, the first two terms rather, I know that this is going to be a circle. Okay, and then it says equals 12x plus 2y minus 37. Okay, so I'm going to gather up all my x's again. So x squared minus 12x. Now I'm going to write plus blank to complete the square. Next, I have plus y squared minus 2y plus blank, and then equals negative 37 plus blank, so I don't forget. Okay, the leading coefficient of x squared is a 1. That's why I can take half of my negative 12 and square it, and I get plus 36. Okay, then because my leading coefficient of y squared is a 1, I can take half of negative 2, square it, and I get plus 1. And so I'll add 1 over there also, and then my negative 37 plus 37 adds up to 0. So this is called a point circle. And let's go ahead and factor this. I get x minus 6, the quantity squared, plus y minus 1, the quantity squared. And there's my equation. The center is my entire graph, and it's the point 6, 1. So if they asked you to graph this, you'd go 1, 2, 3, 4, 5, 6, 1, and you'd say, all right, there's my graph. It's just the center, and that's it. Okay. Let's see. That was Sarah's 220. Okay, 220, number 30. All right, here's where they give you a picture of a circle. And there are two things we need to be able to write the equation of a circle. We need the center. Okay, we need the center, and we need the radius. All right, so they have given us the point negative 5, 5. And the point 3, negative 1. I don't know how great of a circle I can draw. Ooh, not very great. Sorry about that. And so if I connect those 2 points, in the center somewhere is going to be my center, the midpoint of that line segment. And then the radius we could also calculate. Let's find our center first, though. So the reminder is that from negative 5, 5, and then the other endpoint being 3, negative 1. To find my center, I want to average my x's and then average my y's. Okay, so the center, or the midpoint, is going to be negative 5, that's an x, plus 3 all over 2. And then positive 5 plus a negative 1, also over 2, because I'm averaging them. And so I get negative 2 over 2 is negative 1. And then 4 over 2 is 2. And so my center is negative 1, 2. Okay, my picture's a little bit off. Okay, now for the radius. I'm going to take this negative 1, 2, the center, and let's say I take this point right here. Okay, so distance formula, I'm going to write r for radius, but it's the big fat square root of difference of my x's squared, so I'm going to go negative 5 minus a negative 1, that becomes plus 1, squared, plus difference of my y's, so 5 minus 2 squared. Okay, let's see, that ends up being negative 4 squared is 16, plus 3 squared is 9, so I get the square root of 25, and that equals 5. All right, so that's the distance, and so here is my equation. Let me write this in red. Okay, center, negative 1, 2. So I'm going to have x plus 1, the quantity squared, plus y minus 2, the quantity squared, equals 25, which is my radius squared. Okay, and there you go. Okay, let's see. Somebody else is typing something. You know what, Sarah, I did actually talk to Mr. McKee after school, and he said he was just going to be very lenient about that problem, okay? All right. Gabe is asking, hey, Big Tony, big number 7 on the quiz, on the big quiz. All right, can I demonstrate 15 on the quiz? I think I already did 15. Sarah, I can't remember. Did we do number 15 for you? I'm not sure where I left off on your quiz questions. I believe that's 15. Yep. All right. Big Tony, you're a little bit late. It's already there. All righty. So, let's see. All right. There we are. Okay. So, Gabe is asking for page 269, which is your review, and number 15 through 18. I'm not sure that I'll do all of those, but let's see what it is. Actually, those are all great questions, Gabe. Okay, so here's what they gave you. Let me write down these page numbers. Pages 268 and 9, because on 268 they give you the picture of what the original graph looks like. Let's see, it doesn't have too many points. 1, 2, 3, and this goes up to 2. All right, so my graph, let me do it in red so it stands out a little bit, goes from 0, 1 to 1, 1, and then 3, 2. So it's just this tiny little piece of graph that looks like that. Okay, so we are to assume that this graph is y equals f of x. Now what they want you to graph in number 15 is, let me write it in black, number 15 is y equals 2 times f of x. In number 16, I'm debating how much room to leave. I kind of want to do it all on the same page. 16, 17, and 18. All right, so 16, they want y equals f of x, and then a plus 1. And then 17, y equals f of x plus 1. And then 18, y equals negative f of x. Yeah, doing all 4 of these is very important so that you guys see both, or all 3, A's, C's, and D's. Okay, so in number 15, this 2 is an A, and that is a vertical stretch. And so what we said you do is you take your graph that has those 3 points given right there, and you're going to multiply each of the y values by 2. Okay, so follow along. Put a little XY axis here. I'm going to go 1, 2, 3, 4. Let me label my 4 and my 2. And then 1, 2, 3. Okay, the first point, I'm starting from lowest and to the left, is 0, 1. I take the y value which is 1, and multiply it by 2, my a, and I get 0, 2. My x stays the same. Okay, now I take the second point, 1, 1. I just take the y value of 1, multiply it by 2. That gives me 2. And so 1, 2 is another point. Okay, the third and final point is at 3, 2. When I take the y value of 2 and multiply it by 2, I get 4. And so here's my new graph that I'm drawing in green. And it's not the greatest example, but I hope you can see that it's been stretched vertically. Okay, that's what an A does, is it stretches vertically. Okay, next for number 16, they're asking us to graph this. You need to recognize that this is a D, and that means I'm going to shift my original graph up by 1. Okay, so let's go 1, 2, 3, 1, 2, 3. All right, what was 0, 1 becomes 0, 2 because I'm shifting it up 1. What was 1, 1 becomes 1, 2 because I'm shifting it up 1. And then what was 3, 2 is going to be at 3, 3 because I'm shifting it up 1. And so here in black is my new graph, and it looks the exact same size and shape, because it is, as my original red graph. I merely moved it up 1 unit up. All right, in number 17, this is my C, but it's in the form x minus c, and so this c equals -1, and that means I'm going to shift to the left 1. So my original graph up at the top, I'm going to move everything over 1 to the left. So let me do this in green. 1 to the left brings me here and here, and then 2, oops, I'm looking at the wrong one. Yeah, I totally just did that wrong. I'm going to do that. I was looking at the green graph instead of the red graph at the top. Okay, let me start over. First with black, I'm going to go 1 to the left, and I only need to go 2 here, and then my y's are staying the same, so I only need that. Okay, now let me do this in green. So my original graph up at the very, very top, my y equals f of x in red. I'm going to go 1 to the left for that first point, 1 to the left for my second point, and 1 to the left for my third point gives me 2, 2. And so here's my green graph. Notice it is the same exact size and shape as the original red graph. It just got shifted to the left 1. Okay, last one. This negative in front of the f of x is also an A, just like we started with number 15. What it does, and you guys saw this on your quiz, and quite a few of you messed up, what it does is it takes your original graph and it reflects it over the x-axis. But you actually don't even need to know that it does that. What I did on number 15 is I multiplied all my y values. This was a 1, this was a 2. I multiplied all those y values by 2. Well, if you just take those same y values and multiply by -1 on this number 18, look what's going to happen. My 1 times -1 is going to become -1. I'll do this in green. Okay, so the x value stays the same, so it's still on my y-axis, but it's at -1 instead of +1. The second point, the y value up at the top, is at +1. You multiply that by a -1, and you get -1. And then my third point was 3, 2. I think that was a 3, 2. Yes, it was. When I multiply that 2, the y value, by -1, I get -2. And so look at this green graph. It is just the same exact thing as the red graph, but reflected over the x-axis. So what was above the x-axis is now below the x-axis. And that's your negative f of x. Okay, Gabe, that was a very good question, 4-part question, but it showed you a positive A, a negative A, a D, and a C. Okay, and that's everything you guys need to know. Okay, there you go. We are coming up to the 8:30 time pretty soon. All right, so I'm going to answer another question from Sarah, and then I think we're going to call it a night. All right. Let's look at 234. I don't think we've answered any questions from that page. 234. Number 13. All right, Sarah, I'm just going to talk about that one. It looks like it's the equation of an ellipse on the left side, but then it's equal to 0. That means I cannot make it equal 1, which is normally what we want the equation of an ellipse to equal. So this does the exact same thing as a point circle does. Okay, it's technically, it would be called a point ellipse, but they don't actually call it that. So I can tell you right now that the center of that ellipse will be 0, 0, and so that's the only point that satisfies that equation. Okay, so it's just kind of a special case scenario. All right, let me look at your 262, number 30, and see if that's a good one. Actually it is. It is a word problem with variation. All right, so it says the force F. This is page 262, and I think it's going to be our last example, number 30. Okay, first let me talk about compressing a spring. If I have a spring hanging from a ceiling and I'm not compressing it, it's just hanging, that's its natural length, okay? Then if I push up on the spring, it's going to compress, okay? So it will be more tightly wound. I'm going to kind of try to make it look like it is more tightly wound. Okay, and that's now my compressed length. This distance between here and here, what it was and what it is now, that's what they're calling x. Okay, and when I read these words, what I just drew for you and explained to you should make sense. It says the force F required to compress a spring x units from its natural length is directly proportional to x. So they gave me the words to be able to write my equation. It says F is, that's my equal sign. I have to have a K, constant of variation, or proportionality constant. And it says F is directly proportional to X. So that means times X. If it was inversely proportional to X, it would be divided by X. All right, but it was direct, so there you go. It says, suppose a force, I'm going to write my information down here. Suppose a force of 16 pounds is required to compress a spring of length 28 inches. That's the original length. But I'm going to compress it to 26 inches. Then doesn't that mean my x equals 2 inches? Okay, so there's the given information. Then it says, find the force. So now I'm going to write F equals question mark. Find the force required to compress the same spring to 20 inches. So it was 28 inches. Now they're saying to 20 inches. That means I'm going to compress it by a distance of x equals 8 inches. Okay, so just like we saw in our other problems where there weren't any words, I've organized my work so that now I can use the first set of information to solve for k. So I'm going to get 16 for F equals k times 2. To solve for k, I divide both sides by 2, and I get k equals 8. If they ask for what they call the particular equation, it's rewriting that F equals k times x, but writing 8 instead of the k. So here's my particular equation. F equals 8x. And now I can answer their question. F equals 8 times 8. So I get 64, and I look at my information. Force was in pounds, so this is a word problem, and so you want to say 64 pounds is what would be required. Okay? All right, it is 8:31. I'm going to say good night. So have a good one, and I will see you guys tomorrow. My students, you should be working on your extra credit review so that you can ask questions tomorrow on that as well. All right, hope that was helpful for you guys. Talk to you later. Bye-bye.